the revolution will not be digitized. You will not be able to opt out or log out to cop out. You will not be able to log in remotely from the convenience of an armchair. It will not be on Google Maps or Tumblr and will not maintain a microblog. The revolution will not be digitized.
It's always easier to work in terms of traces. In statistical mechanics, that's called partition function. That's the thing that's really accessible. But when you think about it, this is not the best way to compute. In statistical mechanics, we go and compute using free energies or cumulants and such expansions, which are organized in such a way that information that we already have is kept in calculation, and we only look at incremental things. That's called cumulant expansion. And same is true of this theory. Here, instead of looking at trace, you compute a determinant, and it all depends on a very simple relation, which I said a zillion times, that a trace log of a trace of the log of a matrix is log of the determinant of the matrix. Totally simple. And what has happened to us, we have used it on the fancy stuff. We use it on evolution operators that depend on x and y, etc. But now we added some finite matrix structure to it. And everything goes through in all the derivations. So I'll just state the results. So we want to know what the spectral determinants, which were claimed to be the best computational method, look like now. The best formula we had until now was to say that the determinant 1, which is now an infinite dimensional one because we are working in function spaces, determinant of an eigenvalue. This is like energy eigenvalue for Hamiltonian flows in quantum mechanics, minus the generator of infinitesimal transformations on densities in a state space, can be written as exponent of the traces. So this was this amazing formula which relates dynamics on the functions defined over state space to the sum, so this is infinite dimensional, to an infinite dimensional sum of recurrent periodic orbits, which are orbits that happen within the dimension of the space. For a slur, 3 dimensions, and depending what problem is, this is all computed on recurrent orbits. We had to look at various ways of evaluating this amazing formula. But the main thing that happens in decomposition, the exponent has become a sum in which terms look like the terms before, but they're just weighted by the character. So each term has a number that depends on the group element associated with the relative prime orbit, and everything else looks the same. Now, determinant is written as a sum of such traces. So determinant will factorize. What has happened is symmetry reduction has brought the group theoretical structure in a block diagonal form. Now, each block is still very big because it's still going from any point in state space to any point in state space, but now it's reduced to a single tile, to fundamental domain. But the group theoretic structure is just finite. It's a number of representations for finite groups, and it's some series of representations for continuous groups decomposed in product. So that means that our determinant should factorize, writing it just for one irreducible representation. You'll have a very obvious form. So it'll be now determinant of our original problem, but this linear operator that evolved infinitesimally the dynamics, think Hamiltonian and Schrödinger mechanics, is now a sum of the operators, one for each. And even though you might not be able to visualize what this means, the right-hand side is totally obvious. It's exponent minus sum of the repeats. Each repeat shows up as 1 over r. When we derive dynamical zeta function, this 1 over r is what annuls this exponent. It produces a logarithm, and we get some product formula. And then each cycle will be just like here, we already have it. It'll be determinant of identity in D minus D-dimensional state space. And up here, we'll pay a penalty for every repeat. We'll have some thing we use to measure observable, and we'll be interested in computing eigenvalues. So now it is S. But now everything else is decorated by group theoretical thing. So observable is computed on the relative prime orbit, and it's computed for the period of the relative prime orbit. And the Jacobian is computed as explained here on the relative prime orbit, but it's repeated r times. We project onto its new representation by the character of the representation appropriate to the group element, which depends on particular relative prime orbit. So now this might not knock your socks off, but it'll turn out to be extremely rewarding once you actually start computing. Someplace in Chaos' book, I quote Martin Gutzwiller, who says, trace formula is not a formula, it's an idea. The problem is, trace formula is the same as, let's say, problem with Schrödinger equation. It takes very few symbols and less than one line to write Schrödinger equation. Then you can spend your whole professional career solving it. And same thing is true of the trace formula. It looks extremely beautiful, but it only makes sense if many, many things are worked out in detail. You need to understand the geometry of the flow, you need to understand stability of the orbits, you need to understand what it means to be transitively connected, so have a ergodic set in which it can be built in. You need Markov diagrams and all kinds of things to make this thing work. So at this level, it's just some abstraction and you don't appreciate it. What really, really helps is working out a few examples. And there are, again, the two examples. A simple one in which you use a group of two elements, which I keep doing, and nobody understands. So for example, if you're solving Ising models in statistical mechanics, you have plus and minus state, and you should be using symmetry decomposition. As far as I know, people don't do that. Then there's a hard thing, which is a non-abelian group of 6 elements, which is permutations of 3-disk billiard, which is much harder, but you understand it intuitively. So I'll work it out only for that example, even though in the book I work it out for both examples.